materials comprise a steadily increasing proportion of the municipal and industrial waste that is easily poorly managed or accumulating in landfills. Since polymeric materials do not decompose easily, disposal of waste polymers is a serious long-term environmental problem, with most plastics gradually disintegrating to form microparticles which finally arrive in the oceans. Total management of polymer waste requires complementary combinations of biodegradation, incineration, and recycling. Biodegradation is the most desirable long-term future solution and requires intensive research and development before it becomes practical. On the other hand, incineration and recycling can become operational in a relatively short time for the improvement of the situation at present and in the near future. Polymers, with their lightweight, functional properties and low cost, are major contributors to mega trends shaping the global economy. However, their contribution to waste generation is significant. High landfilling rates and mounting global pressure of environmental leakage are important considerations that have raised concerns across regions. According to Frost and Sullivan, global polymer production estimated at approximately 381 million tons in 2021 will reach 528 million tons by 2030. Global polymer waste generation, which accounted for about 95% of the polymer production in 2021, will reduce to 86% of the production by 2030. Asia currently contributes to 50% of total waste, and 50% of this is by China alone.
Challenges on polymer waste management. First, limited recycling infrastructure. Malaysia faces challenges in developing adequate recycling infrastructure for waste tires. The lack of facilities for tire shredding, recycling, and processing hinders the sustainable waste management practices. The present waste disposal measure as not as efficient as the cost water, land, and air pollution. The landfills used to dispose of rubber waste have become limited as they occupy a large land area. It challenges due to the reinforcing material added into the rubber to improve its properties and applications. Hence, waste tires can lead to environmental pollution, soil contamination, and respiratory health hazards due to the release of toxic chemicals and emissions from the burning tires. As for plastic waste, it possesses a threat to the environment because plastic do not degrade completely when buried in landfills. Unlike food or paper waste which degrade, plastic waste breaks down into smaller plastic fragments. The small fragments, commonly known as microplastic, that can leach out the landfill in water and contaminate the local water courses. Next is litters around the street, rivers, and ocean. These have to be avoided, which is we, the Malaysia, encourage the recycling of plastic waste as the government of Malaysia initiated the National Recycling Program and the National Recycling Day, and a mandatory separation of household waste act was introduced in 2007. However, no proper facilities have been put in place to support the mandatory waste separation and a proper dissemination of information regarding the act that has been neglected. Plastic waste will build upon the planet's surface for reducing the landfill space while also contaminating the environment in a way that unstoppable.
Next, I will explain the opportunities that can be taken for the polymer waste. There are several promising opportunities for recycling polymer waste, which is chemical upcycling, radiation technology, effective recycling, and coupling efforts. Chemical upcycling of polymers can transform waste plastics into feedstocks for higher value products like new polymers, molecules, or materials of similar or higher quality than the original. This includes polymer to polymer, polymer to molecule, and polymer to materials recycling approaches. Radiation technology can be used to degrade and modify polymer waste so it can be reused in concrete, asphalt, new plastic products, or as fuel components for energy recovery. This presents opportunities for environmental sustainability and material innovation. Effective recycling of mixed plastics waste is a major challenge, but advances in sorting and separation technologies within recycling plants can increase recycling volumes and eco-efficiency. Rationalizing the diversity of plastic materials used, especially in packaging, could dramatically improve post-consumer recycling effectiveness. Lastly, coupling efforts to increase use of recycled plastics with improving recovery rates of plastic waste from landfills can enhance the environmental performance of the polymer industry. Recycling provides opportunities to reduce oil usage, carbon dioxide emissions, and waste requiring disposal.